AI has completely changed the way the software engineers write code. A lot of it is good, a lot of it is bad. Let's talk about it. So really the motivation behind this video is I want to clear some things up, both in how I've been mentioning using AI for programming. Like for example, I wanted to make a new game engine series that used AI for programming. And as expected, that was slightly controversial, but also my latest full-time project, Lucky Robots. A lot of people seem to misunderstand what is actually going on there, so I'll talk about that later on at the end of this video. Let's cover some facts real quick. As always, this video is just my thoughts and my subjective opinion. Feel free to disagree in the comment section below. In fact, please do, or agree, that's fine as well. It drives engagement either way. This video is also not scripted, it's just me talking, although I do have some dot points. Speaking of facts though, I think we can all agree that there has been a very big change in the software engineering industry, possibly like the biggest change in the history of the industry, dare I say, which of course is this whole AI concept. Like it started softly. It started with like AI autocomplete. I think with GitHub Copilot, that's probably my earliest memory of anything like this. And then it sort of grew into, I guess, ChatGPT and like other chats, other LLMs that you could just talk to in English and it would sort of do the research for you and aggregate all of the sources and hallucinate a lot as well and give you the answer in quite a lot of detail to what you asked it. At that point also you could just grab files of code and attach it to your chat and be like, hey, what's the bug in this code? Or can you rewrite this in a different way? And it would sort of do some things. I mean, I did like a university assignment using AI. I did a video on that like a few years ago. AI was much more primitive back then, but it was still kind of interesting how it did a decent job, I guess. Like all things considered, that versus nothing is still like quite a good job of writing this university assignment that sort of suited things, but then of course I code reviewed it and there were issues and like it wasn't the best, but it still was able to generate some code for you and that was cool. And then I guess it grew into just the ability to have so much more context. So you could just open like a folder in something like Cursor and it would be able to kind of reason about your entire repository of code. And I mean, the biggest thing for me, like a year or more ago, probably more than a year ago, was always AI is fine for like generating little snippets of code and thinking about very small code bases, but like I could never use this on a game engine because there's just too much. There's just too much going on. Like there's no way that it has enough context to make sense of the entire code base. But then that kind of changed, right? And there's obviously a lot of clever things that companies making AI products can do to sort of try and compress what is actually going on in your code base. But still, like when I tried Cursor for the first time in October last year, it was my first experience of being like, I can open Hazel. I can open this engine, which, you know, is not huge. It's maybe 150,000 lines of code, just the Hazel code, not including any of the third-party dependencies, of course. And it was able to still sort of go through all those files and I could ask it questions about the code base and it would do enough research and kind of burn more tokens going down rabbit holes to try and figure out what exactly was going on, you know, in the code base to answer my question. And I distinctly remember being absolutely blown away by how it could just go in and change stuff in the code. And the thing is, like, you know, the quality wasn't amazing. It wasn't like I was looking at this being like, my goodness, this is just such a better programmer than I could ever be. It wasn't that. It was just the fact that I could ask it about this or I could tell it to write some code to do something for me and it just could do it. Like that was just mind blowing how it can sort of do this self-guided research into various parts of the code to figure out how the engine was put together, which it's not like I gave it an architecture document or anything. It just was able to do its own kind of spelunking through the code base to try and figure out how things worked and then write a solution to what I had asked for that, you know, was like maybe junior to mid engineer level, potentially, depending on the problem. But it like worked, it functioned. And I immediately thought at the time, like, hey, with some guidance, like this is just extremely useful. And especially for like writing out things that are easy, because the fact is that, you might be a senior engineer working on a code base, but like you write a lot of code that a junior could have easily written as well. It's not like the problems you're working on are, every line of code that you write is like senior level. I mean, maybe it depends on like the discipline or the industry that you're in. Like, I don't want to generalize programming across things like front end web development and like driver programming or something. But the point is that as a senior engineer, like you wouldn't, the brains is almost in just the architecture and the design of everything you're working on, right? It's not necessarily in all of the lines of code that you're actually writing. And also, I mean, I could say that algorithms are something that a senior engineer might pick more sort of niche algorithms, or even design their own algorithm that would do something, rather than just having a very basic set of tools due to their lack of experience, if we're talking about a junior engineer. But then AI would probably be better at implementing an existing algorithm than a senior engineer, because it's very common for someone to write an algorithm, an implementation of an algorithm, and just make subtle mistakes here and there. But if you have AI write it for you, then it has so much existing reference to draw from, and it can just do the hard work of validating the inputs and outputs. And like, you could cross check it with other AIs as well if you really wanted to. And I feel like overall that gives you a potentially more robust algorithm implementation than if one senior engineer was to sort of do it and then maybe someone else reviews the pull request and they're like, I'm not going to read the paper on this algorithm. I'm not going to like bring up some sample code. Like, yeah, that seems reasonable. Like, and you've tested it, and maybe I'll test it. It works. Like, PR approved. Now, when it comes to using tools to help you develop software, I can think of few that are more important than a visual Git client, such as Gitkraken, the sponsor of this video. Using version control, which for most individuals and teams means using Git, is like at the heart of every software project. All of the development flow goes around using Git, so how can you not use a good, strong visual Git client to help you with that? Gitkraken gives you a really clean and powerful view of commits, branches, merges, all of the important stuff that is going on inside your software project, and it's a much more superior option to simply using the Git command line. I mean, look at this, for example, in the Hazel repository. Try and make sense of all of that versus a beautifully rendered visual commit graph that just helps you visually picture everything that's going on. One of the most important things that software engineers need to be able to do when working on a project is to actually understand what is going on in the project. Who is working on what? Where exactly did things diverge? How do I merge this branch into here? For that, using a visual tool is super important, and Gitkraken makes it really easy to navigate through history, see all of the diffs, all of the changes that have happened with each commit, filter what you're looking at, and just make sense of the entire workflow visually. Gitkraken's visual commit graph does a great job of this and just makes the entire process of software development much easier and more intuitive. And in version 12, they've introduced this new agents section where you can keep track of your running AI agents. Very in line with what we're discussing today. So if you want to stop working blind in Git and just honestly have an easier workflow, then check out Gitkraken using my link in description below. It's free to try, and you can get 50% off Gitkraken Pro by using my referral link. Huge thank you to Gitkraken for sponsoring this video. This is getting very derailed from my dot points, but that's a basic look, I guess, at AI. And so since like last year, and since I started using it for the first time to actually write code in like October last year, it's sort of just mostly gotten better. And then I think, I switched from using Cursor to using Claude. I mean, so when I used Cursor, I went sort of in between. I think it was like some kind of GPT codex. I don't know what version, maybe 5.1 or something, 5.2, those sort of ring a bell. And then Opus, probably 4 point something. Maybe Sonnet as well, but basically going between like OpenAI and Claude, with OpenAI and Anthropic were like the two sort of ones that I ping-ponged between depending on the problem. But then, Claude Code became a thing, or a bigger thing, and using Claude Code from within your terminal, Claude Code CLI, I guess it's called officially, using Claude from within the terminal, like that also became, in my experience, just better, I guess, than Cursor. I mean, I liked the visualness of Cursor and just the fact that it's just VS Code. they just glued together like VS Code and existing third-party AIs, and just made this app that I'm sure has like a lot of sort of like transforming both the user inputs and the AI responses, and probably a lot of middle manning in there that makes it work the way it does. Otherwise, it wouldn't be worth like $60 billion, right? You'd hope. Can I just say something as well? That isn't it just wild that like sure, like Cursor hasn't been officially acquired for $60 billion, but there's this pitch to acquire it potentially for $60 billion, which is like the same amount that Electronic Arts was acquired by the Saudi Arabian company. So all of EA, with its like 30 plus year history, is apparently worth the same as Cursor, which is VS Code plus LLMs. Isn't that just wild? Like, what universe are we living in? Anyway, so the cool thing about Claude was that not only was it, in my opinion, it sort of became, I guess, more capable with dealing with more complex issues than Codex was, or like the GPT 5.1, 5.2, 5.3, whatever. Opus, especially like Opus 4.6, seemed like the good model at the time, but Claude had also introduced Claude Skills, which I guess everyone has sort of adopted in one way or another now, but being able to write skills of things that you wanted it to like agentically do, and also how it should write code in your code base and what things it should consider to try and mitigate all of the issues that it brought, like that was I guess reason enough to sort of switch to it. And in my experience, like it worked pretty well, uh you know eh, compared to the other AIs at the time. Still very far from perfection, whatever that would look like. And I think that, everything was going great with Claude, but then 4.7 came around, and Opus 4.7 was just, in my experience, just a bit of a disaster. I think they tried to reduce the amount of tokens that it uses, and so it ended up just doing stupid things where it just refused to expand or go down rabbit holes of certain areas in your code, and then it just ended up coming up with really bad solutions. They appeared to be very tunnel vision, like it would just sort of write some inline code without even making a function of things that actually, I mean, to give you a concrete example, perhaps one thing that I remember it did was I need to do some string operations. And so it didn't look at like what else was in the code base, and it didn't even really look at much of the standard template library functions. It just decided to like C style iterate through characters one at a time within an existing function, by the way, which was an immediate mode UI drawing function, and then do the transformation of that string, just there, which is like Opus 4.6 wouldn't have done that. Anyway, I think we're getting a bit too specific with various AIs, but I have been using AI a lot, like as part of Lucky Robots, and the fact that I'm the CTO of a startup, so I'm still doing a lot of hands-on engineering, and there's like maybe 15 of us at the moment, and the office in Melbourne is like 5 people. But either way, like I'm doing a lot of hands-on engineering, and I'm working with some really talented engineers as well. And we've had a lot of exposure, I guess, into all of this AI stuff. And again, like honestly, a lot of it's very good, a lot of it's very bad. And that's sort of what I wanted to talk about today, because I think that a lot of people misunderstand AI perhaps, or they give it like a really bad rap. But I think that it's, at the end of the day, it's a very, very useful tool that's probably only going to keep getting better. And so the fact that people have this potential misconception about it, or aren't really quite sure how they should use it, and especially if you have less experience and you're more of a beginner, that there's a special way there as well as to how you need to treat it. And that's why I wanted to put together this new game engine series, because I thought that like I would be able to show people my opinion on how to use AI, and like a better way potentially to like leverage the power of AI, but still be in charge of the engineering of the product, because that still needs to be done by an engineer. But then it would make sense to use AI, because why wouldn't you? Like that's just how software engineers write code these days. Like it or not, that is how this works at the moment. Just like, you would use an IDE, or you would use like a text editor with a bunch of IDE like features. Like you would use a debugger to debug your code instead of log messages everywhere. That's just like what you do because that tool is available to you and is good. AI is also a tool that is available to you and is good in some ways. I feel like I keep having to say that, but it's a net positive in my opinion. And so if you were to actually write a game engine or make a project these days, you would probably want to use it. And so if you are using it, how do you make sure you're using it well? How do you make sure you're still doing the whole engineering thing? Like, it just made sense to sort of update that. But then also the fact that it is available and it does accelerate so many things means that as a solo developer in the scenario of making a video series about a game engine, it would enable me to just do so much more within that video series and hopefully show people how they can build their own tools much easier than they otherwise would be able to before AI became what it is today. If you think that series is a good idea, let me know in the comment section below. If you think it's a bad idea for whatever reason, let me also know in the comment section below. But either way, I think I'm going to make it because I kind of want to make it. And we've talked about how I'm like this new YouTuber now that obviously YouTube is not my full-time job anymore. It's like just like a side gig. And I'm mostly doing it for fun. So therefore, I kind of just want to make that series. I want to have some fun working on another game engine from scratch, and why not just record that and hopefully make it into an educational series as well. So, negativity. Negativity surrounding AI. Why are people negative about it? I think that it comes down to two different reasons. One is that engineers are scared that it will replace them. I mean, a lot of people, not just engineers, are scared that AI will eventually replace them. That makes sense. It makes sense why you would be negative towards something that would put you out of a job. But I would tend to agree with the argument that it's not going to put you out of a job. It's going to change what your job is, hopefully for the better. Then the second point is that it's just not very good. AI just produces inferior code to what I would write, and therefore it's bad. Why would I use it? I'm just going to get all this AI slop and all these vibe coded apps that are just terrible, and software is already in a state where it's pretty bad. Like, I read this article from 1995 recently called A Plea for Lean Software by Niklaus Wirth. I'll have it linked below because it is an absolutely amazing read. Like, it's 31 years ago, and yet it is incredibly relevant. Like, it is just so relevant to like today, even though it was 31 years ago. It's insane. But his whole point is that software is getting slower more rapidly than hardware is getting faster, right? So hardware is obviously getting faster and faster, and we have extremely fast hardware these days, but software still runs pretty badly. A lot of software runs pretty badly. Why is that? Why does software from the 90s sometimes feel snappier than software these days? And this article is exactly about this, and it gives some pretty practical things that you can do, such as like keeping it simple, which sort of ties into a talk that I did at a conference called The Beauty of Simplicity, Making Your Own Technology. I'll have that linked below as well. And I really like this last section here. With Project Oberon, we have demonstrated that flexible and powerful systems can be built with substantially fewer resources in less time than usual. The plague of software explosion is not a law of nature. It is avoidable, and it is a software engineer's task to curtail it. And actually, just looking at a little bit above that quote, I mean, again, this whole paper is gold. Please read it. I'll have it linked below. But here he says, it is infinitely more demanding to design a publishable program than one that runs, right? Infinitely more demanding to design a publishable program, in other words, something that's actually production ready and ready for release, than one that runs. And that's the thing with AI. It can make things that run. But we now know, thanks to Wirth, that it is infinitely more demanding to design a publishable program than one that simply runs, right? So this is where this whole like replacing engineers, replacing people who are programmers and used to actually do all this is not really how I look at it. It's more like, we used to use hand tools, like just a regular screwdriver to do things. And now we have this introduction of power tools that just helps so much. Like you still need a user operating those things. It's just that the task of like screwing in a screw is now much faster and more powerful, quite frankly, than it used to be in the past. And hand tightening screws or working on delicate things where power tools might not be the best option is still a thing. Like carpenters will still use normal screwdrivers, but they also have this new thing that's unlocked to them. You know, they can use impact drivers to just like drive screws into pretty tough, like dense, I guess, wood. And it greatly increases their stamina because they don't have to physically do the work. It's sort of being done for them. And it's certainly so much faster. And that's a decent analogy to AI being used to write code for you. And also kind of brings me to that second negative point, right? Which was about the fact that the code it writes is inferior. Like, yes, AI is mostly trained on code that is out there. It's trained on common code, not just high quality code. And in the case of C++, for example, there is a lot of really bad code out there on the internet. Like I made a video not too long ago about timers in C++. Like this thread on CPP reference, I think, about how to start a 5-minute timer and just the absolute train wreck of all of that code. And people in the comments were, yeah, they were joking about it. They were like, this is what AI is trained on. And yeah, like that's the thing. It's trained on a lot of common code, not high quality code. Some types of code is just much more available than others. Like there's a lot of C++ code out there, but if you look at front end web development, the internet is available to us. And like front end, this is the code that you are downloading onto your computer so that your browser can render it and make the app functional and respond to it, right? Like this, all of the internet is there. The source code is there because you need it to do something in your browser, right? So that entire front end web dev, which in my experience, like I made a website recently for a friend and I used Cursor for that. And that was the first time I made any kind of website. It was just like a statically compiled like HTML site. I forgot what tool I used for it. But anyway, as in what like HTML static site compilation tool I used for it. But anyway, the point is front end web development in Cursor is just like, that's like, I don't want to say it's solved because I'm not a front end developer and I certainly don't want to throw shade at anyone, but like that job is just different. Like centering a div used to be like a thing. Now you just ask AI to center the div for you. You can ask it which div, how would I best lay this out, change the color of this. You don't have to go through like this whole inheritance of CSS classes or anything to try and figure out how do I actually change my bloody font size though. No, you just say do that, it does it for you. Like that has changed. And I think that part of the reason why that seems to be so good, at least to a non-expert, is because there's just so much available in that domain. Like the whole internet is there. Just crawl like every site and get its source code, which you need anyway. And then that's it. Like you can sort of train on that. C++ and other languages are different. So yeah, there might be this variety of quality that you get. But the point is that the quality that you're getting anyway, you know, you need to be involved in the engineering of this thing. This is not something, what I am kind of against is people trying to build apps completely automated or like very agentically to the point where they just have like this whole cluster of sub agents that are just deployed and doing all of this stuff autonomously. And when it's done, maybe someone else, another agent reviews it. You've got your like designer that designs all this stuff, and then the architecture documents, and then the engineer agents will like go and sort of do that, and it's all running while you're sleeping, and you wind up with this vibe coded app that is probably terrible and very much in the functional group, but not the actual, you know, production grade, publication ready type. You need to be super involved in the code that it is writing for you. You need to create good guidelines for how you want it to write code for you that fits within the project that you're working on. You have to give it as much context about the project you're working on, such as a game engine and how it's architected and what the goals are, what it's trying to be, what is important to it, how it should like handle memory or strings or formatting or whatever it might be, like what libraries or what building blocks are available to it. There's so much you could list for it that would make it function so much better than just dropping it in blind and having it sort of crawl the code base, and decide where it wants to spend tokens, learning more and where to sort of try and save that. And then like that's a bit of a disaster. And then even with all of that, when it does write code, like you read every line of code that it writes for sure, and you iterate over it, and you might tell it like, the amount of times it's written something, even with all the context that I've given it. And I'm like, no, like you are, for example, deciding to load another instance of this texture, of this image to use in a UI component, but we literally have a central resource pool where you can just request from that kind of asset manager this thing that I know for a fact is already loaded, by the way. So let's not load another instance of it into GPU memory just for this thing, kind of very ad hoc way. You still need the knowledge of your own code base and the awareness to be able to do these things. That's how it is currently, right? That is like, as of like this month, I mean, May just started. So as of April 2026, that has been my engineers' experience, right? All of my engineering team and me, that is our experience of what it is like these days. It's still very much like you 100% need to know what you're doing. You need to audit every code that, like every line of code that it writes, and we of course open pull requests, and we'll have other real engineers review the pull requests that are made by other real engineers that used something like Claude Code to write probably the majority of the code, but still understand what they're doing. There's still that whole software development pipeline that makes sure that, yes, two human engineers are basically always aware of every line of code that is pushed into like our code base. And presumably because they're real human engineers, they also have experience and they know what they're doing and they know how our code base works. And they have a lot of the, I guess, even just like the business needs of the company, like the fact that like what's going to happen in 6 months, what's going to happen in a year. Like, does the way that it's working on this feature make sense with, that timeline and with future expansions or maintenance or pivots or whatever scale it, that will happen? And that's really important, especially if you're in a startup, because things tend to scale and they can scale quite quickly. This is like a podcast. I'm worried this is becoming too long. Like, you guys, let me know if you're enjoying this and if this is dragging on. I don't know how much of this I'll edit out. I'm going to edit it myself. Yeah, I might have to bring back the Cherno podcast, except this time it's just me. So anyway, you set up all the skills, all the context, all of the guidelines for your agent to run. You prompt it like, well, okay, so that's another thing. Like we can talk about prompting a little bit, but like prompting is also super important and also can determine how many tokens and how much usage you're actually using, right? Because you could say something really stupid to it, like fix this bug where I click on this button called blah, 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 and it does nothing. Or you could be like, you could tag a file that has the functionality and describe the problem to it in much more detail and be like, so on line 90, there's like this button click thing and it's not going through or whatever. Even if you spent some time debugging it yourself, maybe you have a bit more context. If you give it that prompt versus the very broad one, then of course it's probably going to be much more accurate. It's going to be a lot more surgical. It'll use less tokens and the end result is going to be better. And so basically what I'm kind of getting at is that you still need to know what's going on. And by the way, let me just quickly maybe mention that this is all, I mentioned at the start that this is obviously my personal experience and my subjective opinion and all that, but I'm in the space of like, C++, core technology, game engine kind of tech with a lot of systems and like, but also a UI and, a game engine is the best way to kind of describe it. Like that's different than potentially someone working in web dev. So like, I don't really know truthfully what it's like in that field, but just remember that the context of this is like C++ game engine development. So what I'm getting at then is that you still need to be an engineer who knows what they're doing, and you're just using this tool to help you write a lot of the code, to potentially brainstorm and come up with ideas as well. You could ask it, I'm trying to do this. This is my goal. What do you recommend? But then it's not like you just blindly accept what it says. you use that as a prompt for you to then go out there and maybe do some research, maybe play around with some stuff, maybe even talk to some other people like that. It can help you come up with a plan and then implement it, but it still involves you a lot. It still involves someone driving this a lot, someone who understands how things work and who has the experience to spot issues with it and correct a lot of the things that it does, because it will, it's a little bit like electricity in some ways, in the sense that it just picks the path of least resistance. Like it will just be like, well, yeah, and especially like, I swear, especially Opus 4.7, they must have really dialed up the aggressiveness of like the trying to like save tokens or something, which I think, by the way, they've reduced recently. I think they patched it or something. But anyway, the point is that in a lot of ways it will sort of do that. And so you really need to guide it and be like, no, but actually do it this way. Or like, how about we change this? Or isn't this going to be an issue? And then it'll be like, good catch. Like, completely didn't think it. I've got so many screenshots that we share in Slack um, about stuff that is just absurd. But anyway, I think that software engineers are very, very safe for the time being. Will it change? Will it get better? How much better will it get? These are all valid questions, and I don't know. I obviously don't know how much better it's going to get. I assume it's going to get a lot better, to the point where maybe it does in fact write very good code that doesn't need much revision and doesn't need much guidance from human engineers. But there's still the whole concept of like, but how are we actually doing this? Like, how are we architecting this? How is it going to work? How is it going to face users? All of that is still something that exists. And that's why, like, even today with Claude, like, and with other AIs as well, the software engineering job has sort of pivoted a lot more into software architecture and design. Again, the engineering part of it is still very relevant. It's just smaller now. It's like not someone who just writes code nonstop based on like some guidelines or some implementation documents or architecture documents that other people have maybe put together. It's them also taking on this role of like, okay, I can sort of spend more time now on trying to architect this because the code gets written a lot faster. And to be honest, what that means is that engineers who know what they're doing can make things a lot faster than they used to be able to. And also can sort of, I feel like good software engineers, after a while, like experienced ones, will sort of develop. I mean, even to be honest, some people are just born with this, I feel. But either way, an experienced software engineer who's like good, they develop like this almost like a sixth sense, like an intuition that's like quite intrinsic to them of like what is good and what is bad. And so you don't even need to like understand maybe the algorithm or the architecture or the way that something is done fully to just be like, that seems wrong or that seems shady. That seems like a hack. Like you just kind of get a vibe for like the code and you're like, that doesn't feel right. And that's where it's so useful with AI, because again, you don't need to know every little corner edge case of the algorithm potentially. You just know that that's just not the right choice. Like that's not going to work the way I want it to work, or it's a bit shady, it's a bit of a hack. Like, let's do this properly. And the amount of times I've had to tell AI, no, let's do this properly, is also very high. And the thing is, like, obviously there'll still be those edge cases where like, okay, you need to go a little bit deeper and you need to do some engineering and you need to figure out all the little bugs, and maybe AI is just not finding them for whatever reason. But this kind of intuition that comes with someone who knows what they're doing means that they can build pretty good applications pretty quickly, a lot more quickly than they used to be able to, which I think is pretty amazing. And on the other hand, whilst it might not be able to find some bugs in some cases, it's also really good for finding other bugs. Like you can just let it loose on your code base and be like, do a thorough analysis of this and find bugs. And it will probably find something that you have in your code base that you didn't realize. And that can happen completely automatically behind the scenes. You could even, if you wanted to, you could even integrate it into like some CI that like will just, I don't know, you probably don't need to do this for every commit because maybe the engineer would have done that themselves. But, or like you can have it run when pull requests are open and then just do like a little bug analysis of like the pull requests or something. Like there's a lot you can do where it will at least act as a safety net that will sort of catch all these things that humans may just not have caught. Like, why not have an extra set of eyes, looking out for you? Like, for that case, it's really a no-brainer. Like, you don't even have to use the try code for that. You're just using it to make sure that things are actually working and that it's sort of maybe caching things that you may have missed. So the other thing is that I have been saying experienced engineer or like senior engineer or someone who knows what they're doing. Like, I've been saying that a lot. And you might be asking, but what about beginners? Or what about people who don't know any programming? Or what about people who maybe are less than a year of experience and they've just started learning programming? Like, how does AI work for them? And for that, I don't have much good news for that. I think that's a tough one. And perhaps like a lot of my audience is beginners, right? And if you're a beginner, then maybe that's almost where the negativity is coming from. Or maybe seniors are looking more at like juniors using AI and then it becomes a problem. And like, to be honest, I guess I agree. Like, if I was learning programming now, and I was immediately thrown into AI tools and I was taught that like, well, you just ask AI to do this for you and then it writes the code for you and then you test it and then it works and then you commit it and then that's done. Like, if that's your flow, like, that is dreadful. Like, that's really bad, because the thing is, what's missing in that flow is you being able to be like, no, that code is terrible, because you don't know. You're learning programming. You might not even read the code that AI made because you don't understand it. Or like, how would you know that you can't like be creating and populating a new SCD vector inside like a hot loop? Like, you won't be like, yeah, bro, the memory allocation there is wild. No, you won't say that because you don't know anything about it. So therefore AI just does its own thing and you're like, well, it works. And so you wind up getting into that like state of, yes, the code works and it's functional, but it's nowhere near like production grade. It's nowhere near like ready for publication. And there's also probably so many edge cases, or it runs really slowly. And to an extent, you could go back and you could ask AI to be like, okay, well, here's a prompt or here's some guidelines that I got from a senior engineer that says that like, I need to tell you that you can't allocate memory in this function, or you can't do this and that. That would probably work to some extent, but it's like you're flying blind. It's like you don't really know what the output is. You can't verify the quality of the output if you're not experienced enough to do that, if you haven't gone through that yourself. And that's where I think it's worrisome. That's a worrying thing, because the next generation of software engineers who maybe have been brought up in an environment where they do use AI a lot can wind up in a state where like they have a portfolio that looks pretty sweet, but they don't actually understand how anything works. It's kind of like you and me potentially. I don't know who I'm talking to, but like, we'll say you and me, who are like maybe have over a decade of C++ experience or something, let's just say. And we're writing code and we understand how things work. Like, yeah, so we understand how computers work, yeah. But do we really know how like the silicon is like in the CPU and how the transistors work and how that code goes into like machine code and it gets compiled and then it gets executed? Like, how does that even get executed on a physical piece of like metal and like silicon and all of that? Like, I don't know how that works. Yeah, I could probably watch like a video on how CPUs are made, but like, I don't know how that works. But I trust the process and I have my higher level thing that I do know how it works, right? So we're almost going up an abstraction layer here to like engineers that maybe don't know that middle C++ section anymore. They just know the prompting and they just know the architecture, the high level kind of stuff, because then they trust that the AI, which maybe in the future is a lot more refined, is now doing things that, they don't really understand, but they trust that it's correct and they don't need to know that layer because they're higher level than that. So like, that's concerning. And so I don't know what my answer would be to someone who is learning programming these days. Like, do I just tell them that don't use AI tools? Like, learn how to write code yourself. But still, like, that might work for the first year, but they're not going to get a job and they're not going to go through a decade of handwriting code. That's just dead, So, yeah. I don't know. I think it's rough for beginners right now. I think it's very hard. When I hire a junior engineer right now, I expect them to use AI, I guess. Like, I would, because their output is going to be much lower than the rest of the team. I mean, they're a junior, so you'd expect that anyway, but still, you would expect them to sort of catch up and use AI, but then that means that they're not getting experience doing actual programming, which might make them harder to judge the quality of AI. But then again, I think you could. I'm just talking to myself at this point. I'm sorry. What I was going to say was that I guess you could still learn a lot about programming from using AI. You just have to be a lot more deliberate about it. You just have to be a lot more like, you know, I'm using AI, but I will make the effort to go through every line of code and understand this, and maybe have a mentor or someone I can talk to about this pull request in great detail. And then they'll be like, yeah, you cannot, like, every time you push back to a vector, like, especially if it's small, you're probably allocating and moving memory and blah blah blah. Like, oh, I didn't even know that. Like, yeah, I didn't know that. Like, now I know that. Now I know that the next time I prompt AI and it does something like this, I'm like, well, nah, I don't like the way you're using vector. Or like, do a little reserve or a resize up front before we get into the loop that pushes back all the elements. Like, you can learn that stuff, obviously, without handwriting it, but you just need to be more deliberate about it. But yeah. All right. Well, thank you for coming to my TED Talk. Thank you for coming to this Cherno Talk. I hope you guys enjoyed. Let me know what you think. I think it's been a very long time since I made any kind of video like this, where I just sit in front of a camera and hit record. To be honest, like, I'm very busy, being like the CTO of this startup. So I don't have that much time for videos. So I would like to make more videos like this in the future, because it's just it's almost therapeutic for me, to be quite honest. Like, I can just talk to the camera, and I mean, I'm going to edit this, which is going to be a chore, but I could always outsource that if I wanted to. The point is, let me know what you think. Let me know if there are some other topics you want me to talk about. I'm planning to talk more about work as well. Speaking of which, I did promise I would talk about Lucky Robots a bit and what I'm doing. So let me quickly cover that. So AI and robotics, right? So a lot of people think I'm working for like some AI company. And like, whilst AI is involved in robotics, I guess, like, we're trying to ultimately develop robots that have their own intelligence, so that they're not like scripted to do one thing, like pick up this thing, this water bottle of mine, and then put it somewhere else. And that's like a direct script, like a lot of like how you would find, robots in factories assembling cars. Like, they have a very specific task that's like sort of hand programmed into them, versus the intelligence of being able to say something to them, like, pick up that toy on the ground and put it into a box, and then it would have the intelligence to be like, all right, well, I can visually see it, it's over there, let me maneuver it, and let me do so, and like, let me maneuver my arm there, pick it up. I know where's that box. Well, yeah, that's probably the box over there. Let me walk over there and put it down, whilst also avoiding all of the objects that are in the way, and doing all of that. Like, that's a more abstract task than just a very tightly scripted loop of instructions. And to develop that kind of intelligence is a difficult task that, lots of companies are sort of trying to do. And I think we've all seen robots doing backflips and just being completely agile and like moving very smoothly. But as soon as like any kind of robotics company is trying to do intelligence with them, or like something that's a bit more complicated, that's like requiring them to sort of think on their own, they are walking like elderly disabled people. And so it's like, sorry to the elderly disabled people out there. And there's a few different ways that companies are approaching this kind of training the robots to actually do something, because at the end of the day, they just need to be very heavily trained on their particular task to sort of, recognize the patterns of it and learn how to actually do it. I'm not going to talk about some of the different ways in which that's happening, but the point is that, we have sort of decided that simulation is a good sort of way to do that, especially at scale, when you might need a million examples of a robot picking up a toy and putting it into a box. Like, how do you generate that much data? Well, simulation makes sense. And so what Lucky Robots is doing is using game engine technology to create all of these scenarios and then capture the data from them, so that we can then train that intelligence on that data that we're synthesizing, is kind of what's going on, right? So in a way, it's not like I'm working on AI. Like, I kind of am indirectly, but it's not like I sit there tuning LLMs or something all day. Like, I'm still, like, we are still actually making this game engine that is like this simulation creation tool that can simulate, well, I mean, the end goal would be practically everything, but in the in the short term, it's just like simple tasks. Like I want to make a scene with like a table and I want to have a robot arm and it needs to pick stuff up and it needs to put this here and I need to do I need to do that a million times and it's all randomized and it's all like good data for the robot to actually train on, that then obviously translates into the real world as well. So that trained kind of brain of the robot then has to be good enough from that synthetic data from the simulator to then be able to also know what to do in the real world. And that like gap between simulation and reality also needs to be closed. So that is kind of what I'm doing. And I want to make more videos about it as well. Like eventually we're going to start publishing our product. And I obviously really enjoy what we're working on. And I think it would be great to share that with all of you. So hopefully if I can find a way to do that that doesn't, add too much friction to my job, I would very much like to do that. Okay, now I think I'm done. So thank you guys. Let me know if you want this in like podcast format or like summarized into 5 minutes by AI, but I hope you enjoyed. Put your thoughts into the comment section below. I would honestly love to read them, and don't forget to hit the like button as well. I will see you guys next time. Goodbye.